Okay, hello everyone. Today I am going to be going through Practice Test B. So remember, this one is not your assignment. The one that is due on Wednesday is Practice Test A. This is B, but I will be going through all of the problems, doing them pretty quickly. So if you do need extra review, I recommend you watch the other videos for that selected section that you need. I am going to go in order. So if you would like to skip forward and go to the question that you need instead of watching the whole video, you are free to do that. Go ahead and use that pause, fast forward, rewind button as much as you need for yourself. Okay, so to start off with, numbers 1 and 2 go together. So for part 1, you are going to just leave it in factored form. You're going to factor the polynomial, leave it in factored form. And then in part 2, you're just graphing it from that factored form that you got here. So since this isn't a lot of room and I don't know exactly how much space it's going to take me, I rewrote my problem and I'm going to do it on a separate piece of paper here, just so I can freely use more room. So starting with this, I can look at this and I know that I'm not going to be able to factor this by grouping because 17 is a prime number. So I wouldn't be able to simplify that very much. I'm going to do this with the rational root theorem, which says that I need to find all of my factors to 75. All right, so I went ahead and I found all of the factors to 75 and make sure that each one has a plus or minus. And then I found all of my factors for my Q, which is my leading coefficient. We make sure that it is written in standard form, and I write the factors to that leading coefficient, which in this case was 2. Now, to find all of my possible rational roots, I need to write all combinations of p's over q's. That means all of my p's over the 1, and then all of my p's over the 2. And that is going to give me my options of which of those in that list can be a factor or a root to my polynomial. So I'm going to go ahead and write all of those out. Okay, so here are all of my possible roots. I did all of my p's over 1, which gave me this, and then all of my p's over the 2, which gave me this. Sometimes when we're lucky, we're able to cancel some of these out because they simplify to something we already have. We can't do that here, so all of these become our options. From here, we want to start off by testing those points. Remember that by using the remainder theorem with synthetic division, we know if something is a factor or not if our remainder is 0. So there's no actual way to go about this. You just kind of have to do it and hope for the best. So I'm going to start off with 1 and then move along that way. I definitely want to start with my whole numbers. You don't want to start off with a fraction doing addition, subtraction, or multiplication if you don't have to. So I'm going to hope that one of these somewhere early on hopefully gives me a remainder of 0. So I'm going to start with a positive 1 and bring down my coefficients. I'm going to do this first one a little bit slow, just as review, if you need review on the synthetic division. Remember, we bring down the first term. So here is a 2. I'm going to bring it down. Positive 1 times 2 gives me a positive 2, and that goes in here. And then we add. So we get a positive 19. I'm going to multiply these two again, and I get a positive 20. 20 plus 20 gives me a 40. Multiply these again, I get a positive 40. And here I would get a negative 35. Since this is not equal to 0, positive 1 is not a factor. So then I'm just going to pick another one. I'm going to say positive 3. If you did this already and you're just watching the video to check your work, you may have picked different points and you may have found one that worked. That is a little bit different than maybe the one that worked out for me first. So if that's the case, it's okay. It doesn't mean you're wrong. Just make sure that our factored form matches. Okay, so where was I? 23. 23 times 3 gives me 69 here, and that's going to be 89. Okay, well, I know that's not a factor because when I multiply those two, it's going to give me a really big number, which is not the positive 75 that I want here to cancel out. So I'm just going to say that does not equal 0. Therefore, positive 3 is not a factor. And then I'm going to test another point. All right, so then I would test positive 5. I'm going to keep going with this pattern until I find something that gives me a remainder of 0. If you don't take as long as I do, that's fine. I'm just going to pause the video here so it's not very long, and I'm going to keep working until I find something that works. All right, and I'm back. So positive 5 didn't work. At that point, the next number was going to be 15, and that was just too big. So I went back and I tested all of the negatives for the numbers I had already tested. Negative 1 didn't work, negative 3 didn't work, but when I did negative 5, I did see that my remainder was 0. Therefore, negative 5 is a factor. But remember, we want to write this in factored form. So I need to turn this negative 5 into x plus 5. You take the opposite of what that number is. So you get an x plus 5. So if I bring down my original equation, which is 2x cubed squared 20 minus 75 there, I can rewrite this as this x plus 5 and what I got here. So remember, I'm going to drop one of the exponents. So from 3, I'm going to go to 2. And that becomes my equation here. All right, this part is already factored, but now I have to try to factor this part here. So I am going to do the x method, but because my a value is not equal to 1, I have to do the x box method. A times c is negative 30. B goes at the bottom, which is a positive 7. My first box is my first term, and my last box is my last term. Okay, so I want to find what two numbers multiply to negative 30, but add 2 7s. So I know it's going to be a 10 and 3, where one of them has to be negative, and it's going to be the 3, just because the 7 is positive, so the bigger number has to be positive. Then I bring those over here, and I'm going to pull out the GCF. So 2x squared and 10x have a 2x in common, which leaves me with the x there. So x minus 3 to get that, and then x plus 5. So this becomes 2x minus 3, then an x plus 5, and I am going to bring down this x plus 5 there. Before I move on, I notice that I have an x plus 5 and an x plus 5. Those are technically like terms, so I am going to combine them. X plus 5, since I am multiplying two of them, that gives me an exponent of 2, so multiplicity 2. And my factored form is this. So going back to my practice test, leave answer in factored form. I am going to write x plus 5 squared, because again there's two of them, times 2x minus 3 as my factored form. For number 2, it is asking me to graph the polynomial, so graph these here. We want to go back and we want to use the zero product property to solve. So here I get x plus 5 is equal to 0, so x is equal to negative 5. Remember, multiplicity 2. 2x minus 3 is equal to 0. And since there's only 1, we could write multiplicity 1, but you don't really need it. So I'm going to bring over this -5 right there, and 3 over 2, which is 1.5. So there's 1, and add the half right there. So I need to know my end behavior based on my first term here, using my chart. So this is positive and odd. So I am going to be looking at this one where we start at the bottom, end at the top. So I'm just going to do it like this and like that. When graphing, I need to remember my multiplicities. The -5 has a multiplicity of 2, so that means that at this point here, I guess I can do it like this so it can fit. At this point, it's going to have a bounce back. It's going to look like a parabola because of the multiplicity 2. So I'm going to go here, and then I'm going to bounce back. Since the 3 over 2 is multiplicity 1, that one will go straight through. So I can just do it like that. And that becomes my graph. Remember your little mountains, so this dip could go as low as you want it to. We're not being very specific with that, but this point has to bounce back at the -5, and this one goes straight through at the 1.5. All right, so I am going to zoom out of here for you to see the whole thing. Now this one took me a lot of space because I just couldn't find the one that actually worked. And then once I did, everything moved by a lot quicker. I found my multiplicities, which I then used to graph right here. That will definitely be the most time-consuming one. And remember that on your test, that is going to be your nearplot question. So it's going to be 2 slides. Leave the first one in factored form if that is what it's asking for. Moving on to number 3, there is 2 sections here. It is saying to write the following polynomial in standard form. Remember, standard form means that the exponents are from largest to smallest. So I want to go through and identify them first. My biggest 5, 2, 6, 4 is the 6, so I'm going to start off with -2x to the 6. I can cross it out so I don't get messed up, and then I have the 5, then I have the 4, then I have the 2, and then I have my constant, which has an exponent of 0. Doing the same thing down here, I have a 3, a 5. I have a variable here, so that means it's an exponent of 1. When you don't have a variable, that means your exponent is 0. So again, starting with my largest, and that is your equation in standard form. For number 4 and 5, I'm only going to do one of them. It should be enough for you. When you add, you are essentially just combining like terms. So I'm going to go through and I'm going to identify what those like terms are. We start off with the biggest exponent, which is this 3. So -4 plus +3 will give me a negative x cubed. Then I'm going to start off, I'm going to continue with the next one. So -2 plus -2 gives me a negative 4x squared. And then I am going to finish off with my last one, which is this x. So 2 plus a -5 gives me a negative 3x. And that's it. When we are subtracting, it is really similar to addition, but with subtraction, you're going to distribute and then add, which is combine like terms. So I'm going to take this negative and distribute it to every term in the second polynomial here. So bring down negative x squared plus negative and a negative give me a positive, positive and a negative gives me a negative, and then again I end up with a positive here. Now I can combine my like terms again. Negative 3 plus a 5 gives me a positive 2. Negative 1, negative 2 gives me negative 3. And lastly, 6 plus 7 gives me 13. Okay, moving on to the next one. Multiply the following polynomials, write your answer in standard form. So again, I'm just going to do one of them. And I'm going to do mine using the area model. Some of you guys prefer distribution, and that's fine. You can do that. Okay, so with this, you want to multiply. Remember that when you multiply, you're adding the exponents together. So this is a 1 plus a 2 gives me a 3. Squared and 2x squared. Then we have minus 15x and 2x, negative 5. So I wrote these out color-coded so that I know which terms I'm going to combine. They're usually diagonal. So here I can just write 6x cubed. I add these two and I get 8x squared. Combine these two and I get a negative 13x. And then lastly, I get this minus 5 here. And that's it. For the next one, it says divide the following polynomials, write your answer in standard form. So because I noticed that this has a number in front of the variable, I can't do synthetic division. I know I have to do long division. So I'm going to go ahead and copy this problem over to another piece of paper and do my work that way, just so it's not crammed in here and you can see it better. When writing this over, you want to make sure that every variable has, or every exponent is represented. So here we have a 4, a 3, a 2, a 1, and then it goes to 0. You don't want to skip any of those exponents. So here's my problem. Remember, I want to know, what do I multiply by this 5x? I'm focusing on the largest term of each polynomial. So I'm focusing on this 5x, and I'm starting off focusing on this 20x to the power of 4. So what do I multiply by 5x to get this 20x to the 4th? Well, to turn the 5 into a 20, I need to multiply by 4. And to turn this x into an x to the power of 4, I need 3 more x's, which is that there. So when I multiply this out, I get 20x to the power of 4, and then I multiply by the next one, and that is 20x cubed. At this point, remember, you need to subtract, which would change the sign here. And you get 15x cubed. Bring this down, which is a negative 5x squared. So again, I'm going to focus on the biggest term and the biggest term. So I need to turn this 5 into a 15. So I'm going to multiply by 3. And this x into an x cubed, so I need my x squared. Multiply that, I get 15x cubed plus 15x squared. So I multiplied that by that, and then that times that, and that's where I got this 15x squared. So again, I'm going to multiply, which changes this sign here. And I'm going to bring down the 35. So this gives me a negative 20x squared minus 35x. Again, I'm going to focus on the biggest term, which is this one. I need to turn this 5x into a negative 20x squared. So I need a minus 4 and an x minus 20x. So that would change that one to a plus. And I would be left with negative 15x, negative 13. Okay, so what do I multiply by 5x to give me this biggest term here, which is a negative 15? I'm going to multiply by a negative 3. So negative 15x and then minus 15. So that would turn into a plus, and this turns into a plus, which gives me 2. Oh, sorry. Which gives me that 2 there. So that means that I am going to add 2 over 5x plus 5. And that becomes my quotient. Remember the remainder, you bring the sign over because that becomes your operation, and then you put it over the divisor, which is this part here. All right, so transfer that answer over to here, and we can move on to number 8. So for this one, I noticed that my x has a 1, so it doesn't really have a number. I can use synthetic division to solve this. I can probably fit it in here, but just for sake of clarity, I'm going to do it on a separate piece of paper. Okay, so I just copied this problem over here, and I'm going to use synthetic division to solve it. Before you start that, you want to make sure, again, that all of your exponents are represented. So 4, 3, 2, 1, and then 0. When using synthetic division, remember you have to take the opposite of your divisor. So here I have x minus 9. So when I do my synthetic division, I'm going to turn that into a plus 9. Since all of my variables are represented, I can write down the coefficients straight in here. If something was missing, for example, this one here, and it just went 4, 3, 1, you would have to fill in this placeholder with a 0. We don't have to do that one here because everything is represented. But if you do come across something that is missing a variable, you need that placeholder. Bring down minus 18 gives me a 2. So here are my coefficients. Remember, I'm going to drop one of the variables. So from x to the 4th, it goes x cubed. And then I just keep bringing one down. This is a plus. This is why I like to put my signs, just because then I can just write my variables and not have to worry about the other part. So this becomes my quotient. Just going to go ahead and write that on here and move on to our last two problems. For this first one, it says factor and solve the given polynomial. So I have to do two parts. For the first part, factoring, I want to see if there's anything that I can pull out here that they have in common. So I'm actually going to do this one in a separate piece of paper also. You could probably do both of these in that given space, but I don't want to make it too cramped for you guys. So I want to know, what do these things have in common? I noticed this 5 here, so I'm going to see if 5 goes into everything, and it does. And then I noticed that every term has an x, so I'm just going to go ahead and pull that out too. And what I would be left with is x squared plus 8x plus 7 is equal to 0. So this one's already factored out. I just have to factor this here. So 7 and 8. Because my a value is 1, I don't need my box. I can just go straight from here, which this would give me 1 and 7 into factored form. So x plus 1, x plus 7, bring down my 5x. So this here is my factored form. So when it tells me here to factor and solve, part of that is to write down my factored form. Now I'm going to go back and solve. To solve, I need to do my zero product property where I set each factor to 0 and solve for the variable. So 5 times something is 0, that something is going to be 0. -1, -7. So I get x equal to 0, x equal to -1, and x equal to -7. Sorry. There you go. And lastly, factor the polynomial. Again, you should have enough room to do that here, but I'm going to do it on a separate piece of paper over here. And I want to try factoring by grouping first. So what do these two things have in common? They both have an x squared. And I would be left with an x minus 3. Oh, sorry, 5x minus 3. What do these two have in common? Well, I don't see anything that they have in common, but I do see something similar to this 5x minus 3. This is a -5 and a plus 3, and this is a +5 and a minus 3. So if I pulled out a -1, I would be left with a +5x and a minus 3. So I'm going to bring down what they have in common, combine what is left, which is this x squared minus 1. Now, for some of you, you would call it a day here and say you're done. You have to make sure that everything is as simplified as possible. And here, I notice difference of squares. A 1 is a perfect square of 1 times 1. So I can say this is x plus 1, x minus 1. Bring down my 5x minus 3. And this becomes my factored form. Right there. So going back to what the question was asking, it is asking you to factor. Only factor. So it wants the factored form. It doesn't want what x is equal to. That is solving. We're not solving here. We're only factoring. Please make sure that you read the instructions and give the answer it is asking for. So I'm going to zoom out here. I know I didn't do every single problem, but I did do one of each, so you should be able to figure it out. Like I said, if I move too fast on one of these, you have the videos in the channel that you could focus on. There is one on arithmetic, which would focus on 3 through 6. There is one on dividing and factoring. I think it's together. I don't remember. The rational root theorem, you have a lot of examples that I did. You have the 4 that are under files, under extra practice, with the answer keys provided there for you. That is all I got for you guys. So if you have any additional questions, please let me know. Remember that practice test A is due on Wednesday. Other than that, I am done. So be good, be great, to be beautiful. I will see you guys in class. Bye.